If you're taking a 4-question true-false quiz, how many ways are there to answer all 4 questions? The simplest way to deal with this is with the fundamental counting principle. Because you have 4 questions, so you have a choice for how many ways you can answer the first question. You've got a choice of how many ways to answer the second question, a choice of how many ways to answer the third question, and a choice of how many ways to answer the fourth question. Now, a true-false test only has 2 possibilities for each answer. So there are 2 possibilities for the first question, either true or false. Same 2 for the second question, same 2 for the third, same 2 for the fourth. So 2 times 2 times 2 times 2 by the fundamental counting principle is 16. So there are 16 different ways that you could give your answers to a 4-question true-false quiz. If you're having trouble seeing that, I will say that you could draw a tree diagram. I'm not advocating that you solve it that way, but just suppose you wanted to develop your intuition a little bit better, or that you wanted to double check and make sure you hadn't thought about it incorrectly, you could draw a tree diagram. The first question could be answered true or false. Each subsequent question could be answered true or false. So each time it branches to a different question, you double the number. And if you count them at the end, you have 16. So there are 16 ways. The fundamental counting principle is obviously the easiest way to handle it, but you could draw that tree diagram. All right, we've got a follow-up question now. This time it says, if you're taking a true-false quiz, how many ways are there to get no questions wrong? Well, the simplest thing here is just to think about what it means to have none wrong. If you think about a tree diagram with, say, C for correct and an X for wrong, the only way that you would get no wrong is if you had the first one correct, and the second correct, and the third correct, and the fourth correct. And if you're thinking about that tree diagram in your mind, that's the only way to do it. Another way to look at it is, again, as an application of the fundamental counting principle. If you want to get none wrong, there's only one way. You've got to get the first one right and the second one right. If you answer true or false, there's only one right answer. There's only one right answer to this one. There's only one right answer to this one, and there's only one right answer to that one. So by the fundamental counting principle, 1 times 1 times 1 times 1 is 1. So there's only one way. Technically, this is a fundamental counting principle problem, but in reality, if you just think about what the tree diagram would look like without even drawing it, you can see there's only going to be one way. So either just think it through and figure this out, or use the fundamental counting principle. Either way, you conclude there's only one way to do that. I want to keep emphasizing the tree diagram as a way to develop your intuition. Again, I'm not suggesting that you solve this problem using a tree diagram. However, it does help you build your intuition to at least think about this. This time, instead of true-false, you're just grading the problem whether it was correct or incorrect. So the first question could either be correct or incorrect. The second question could either be correct or incorrect, and all the way down. You get the same 16 possibilities, but if you're looking for none correct, none wrong, the only branch that gives you none wrong is this one. So there's only one way. Again, one way. I want you to be able to work these problems efficiently, but I also want you to build an intuition of what you're doing behind the scenes. So even if you don't draw the tree diagram, you sort of have a visualization of that. Okay, we've got another question related to this same problem. Same 4-question true-false quiz. This time they want to know how many ways are there to get one question wrong. If you want to avoid drawing the tree diagram, I would recommend that you think of it this way. Remember, we got this same 4-question quiz. Suppose you think about taking the 4 questions, just call them question 1, question 2, question 3, question 4. Think about dropping them into a writing the question numbers on a piece of paper, dropping into a bowl, and just randomly picking one out, and the one you pick out is the one that's wrong. That's just like saying how many ways can you pick uh, a person from a group of people to do some task. In other words, I could think of this as a combination problem. If I wanted to get 2 questions wrong, I'd be choosing two pieces of paper from the bowl. If I want to get 3 questions wrong, I'd pick three pieces of paper from that bowl, and the question numbers I choose are the ones that get counted wrong. So in that sense, you could think of this as a combination problem. And you'd be choosing from among the 4 questions, but you're only picking out, if you only want one to be wrong, you're only drawing one piece of paper from that. And of course, that's going to be 4. So there are 4 ways to do this. Remember, you can do this on the calculator if you absolutely have to. With your, you have a factorial button, which is shift 3. You have a combination button, which is shift 2, and you have a permutation button, which is shift 1. So if you wanted to do that on the calculator, you would put in 4, then you would do shift, and remember we're using the Casio FX 260, and shift 2 is the combination. That's the combination button on the calculator. But we're not doing combination 2, we're doing combination 1, excuse me here. And then you would put in the 1 and hit equal, and that would give you the 4. Once you did that, you would get 4. So that's one way of thinking about it. For just getting one question wrong, you can also sort of picture the tree in your head. The only way you can get one wrong is you could miss the first one and get the other 3 correct. You could miss the second one and get the other 3 correct. You could miss the third one but get the other 3 correct. Or you could miss the fourth one and get the other 3 correct. And so again, you get 4 ways to do it. So for just getting one question wrong, you could probably just think it through without even formally using any mathematics or any of our little tricks. But this really is a combination problem, and the reason I want to emphasize this solution is that as soon as you change the one question wrong to a higher number, then it becomes much easier to think of it as a combination problem like here rather than as just writing out the possibilities. But either way, on that particular problem, the absolute quickest way to do it probably is just to think in your head about the possibilities, and you'll get 4 very quickly. But it is a combination. And just stay with my pattern. I will say again, I'm not recommending this as the way you should do it, but you could, in fact, get that same answer from the tree diagram by noting the branches that give you one wrong. That branch gives you one wrong. That's 1. Any other branch down here, you've got 2 wrong unless you go this way. So if you choose another color, you could go here, that would be another possibility that has just one wrong. Then you could do, let's see, you could go here and move down, and that would be one wrong. Now any other branch down here, since you've already got one wrong, you can't choose any of the rest of these because you're going to get another one. So you'd have to go over here to see if there are any more. You've already got one wrong at this point, so the only way you can go down this branch is to go down the branch where nothing else is wrong, and that would be this one. And then you can scan through, but there are then just 4 ways to do this. So one way here, that would be a second way, that would be a third way, and that would be a fourth way. So again, I'm trying to build your intuition here. I'm not suggesting that this is the way you should do the problem. On the other hand, it does work if you have the time to do it that way. There's yet another question. About this same thing. We're still taking the 4-question true-false test quiz, but this time they want to know how many ways are there to get 2 questions wrong. Now this is what I was talking about earlier when I said it's really better to think about this as a combination. If you think of the question number 1, 2, 3, 4 being written on a piece of paper, put into a bowl, this time you want to draw out 2. You don't care what order you draw them out in, because whichever 2 you select from that bowl are going to be counted wrong. So it's a combination. We're choosing from the 4 question numbers, and we're going to pull out 2. We don't care what order we pull them out in. We're just going to pull out 2. So that's definitely a combination. And if you want to calculate by hand, you may. But if you want to use the calculator, you enter 4. Then the symbol or the key for combination on the Casio FX260 is Shift 2. And that Shift 2 is the combination key. And then you put in 2 and equal. And when you do that, you'll get answer of 6. So there are 6 ways to get 2 questions wrong on a 4-question true-false test. And as I said before, just to develop your intuition more than anything else, we could actually go in here and mark off all 6 of them that have 2 wrong. I don't think I'm going to do that. Well, why not? I'll try it. If you want to get 2 wrong, you could go down this branch, but since you've already got 2 right, the last 2 have to be wrong. So that's the only way you can go down that branch. If you go down if you stay here and go here, you've already grabbed 1 wrong. You can get another one correct and another one wrong. That would work. You could go down this same branch and get that one wrong, that one wrong, that one right. That'd be 2. Can't go any further down that branch because that'd cause you to get 3. So then you could move over and start here. If you get 1 wrong, then 1 right, and then another one right, now you've got to get 1 wrong. Staying here, if you get 1 wrong and then another one right, you could get 1 wrong here, but then you've got to get 1 right. And you can't go down here because that'd be a 3rd one wrong. And you can't go here because that'd be a 3rd one correct. So moving down here, you could go wrong, wrong, and then right, right. And anything beyond there is not going to work. So if you count these things, you've got 1, 2, 3, 4, 5, and 6. Again, I'm not advocating that you do it this way. I'm trying to help you build your intuition on how these things work. One more question about this 4-question true-false test. The last question about this 4-question true-false quiz says, if you randomly guess at each answer, what are your chances of getting 3 or more correct? Well, if you want to stay with what I've been doing, which is just doing it without the tree diagram in the beginning, you would have to think of this. 3 or more correct, what does that mean? Well, let's look at it explicitly. The number of ways of getting 3 or more correct, what that really means is you could either get 3 correct, so the number of ways to do that, or you could get them all correct. All 4 correct. So 3 or more means either 3 correct or all 4 correct. Now we know these are combinations. We've already been through that argument, so we know the setup is going to be this. We know we're choosing from 4 questions, so those two numbers will be 4. If we want to get 3 correct, that'll be 3, and to get all 4 correct, that will be 4. And again, using the shift 2 on your calculator, you will come up with 4 for that and 1 for that. So there are 5 ways to get 3 or more correct. And notice we haven't drawn anything, but we've now gotten into the routine of realizing these are combinations and just doing them. However, in the spirit of building your intuition, if you did use a tree diagram to answer this question, you want 3 or more correct. Well, 3 or more means 3 or 4, so it's easy enough to do the 4. You just go down here, you've got 4 correct. But now 3 correct, let's look at that. 3 correct could be the first 3 correct but miss the next one. And remember, 3 correct also means just 1 wrong, so you can also think of it that way. If you go this way, you can go correct, correct, wrong, correct. You can't go down that branch because you would have a second correct. You could go here and get 1 wrong here, but then you can't go wrong anymore, so you've got to go correct all the way through. So that looks like the end of that. Moving over here, you've already got your 1 wrong here, so you can't do any more wrongs. Which means you can't go down any of these other paths. So if you count, you've got 1, 2, 3, 4, 5. Again, I'm not advocating that you build these tree diagrams when you're solving the problems on a test or quiz, but I am saying it's nice to be able to connect the calculation back to the visual, and maybe that'll help you build the intuition. And if you somehow panic and just forget how to do the calculations, you do have a backup method as long as the number of questions is not too large.